Hi everyone, here's your questions for lesson Algebra 2B, lesson 95A. We're going to do numbers 1 through 5 and then 9, 11, and 12. So the first one, number 1, is a word problem. So it says, Weatherman Bob walked the campsite at 6 kilometers per hour. Then he caught a ride home on an old truck at 24 kilometers per hour. If he was gone for 10 hours, how far was it to the campsite? So for number 1, we have a person that's driving out or walking out and then driving back. So we have the distance to the campsite is equal to the distance coming back. And we are given some information. It says that he walked at 6 kilometers per hour. So this would be RC was 6 kilometers per hour, and then he caught a ride back at 24 kilometers per hour. So the rate back would be 24. Then it says that he was gone for a total of 10 hours. So that means the time to the campsite plus the time back was equal to 10. And you need to solve for one of those letters, either TC or TB. It doesn't matter which one. I'm going to choose to solve for TC. So TC would be equal to 10 minus TB. And you know that distance is equal to rate times time. So DC would be equal to RCTC, which is equal to RBTB. RC we know is equal to 6. TC we know is equal to 10 minus TB. And we know RB is equal to 24, and TB will just be TB. Now, if you distribute your 6, you're going to get 60 minus 6 TB equals 24 TB. And we're going to move this 6 TB to the other side, which means that we have 60 is equal to 30 TB. So therefore TB is going to be equal to 2. Now if TB is equal to 2, then I know that TC is equal to 8. And what I'm trying to find is the distance to the campsite. So distance to the campsite is going to be equal to the rate to the campsite, time of the campsite. And we are given that the rate to the campsite was 6 and the time to the campsite was 8. So our answer is going to be 48 kilometers. Now moving on, we're going to look at number 2. It says the alcohol concentration had to be exactly 52%. How many milliliters of a 60% solution should be added to 200 milliliters of a 20% solution to get the proper concentration? So for number 2, we're adding 2 solutions together to get a final solution. We know that our final solution needs to be exactly 52%. We know that we are starting with a 60% solution, and we don't know how much of that, but we know that we're adding that to a 20% solution, and we know that we have 200 milliliters of that. So we would end up with X plus 200. So now what you're going to do is you're going to make your equation. So we should have just one equation of 60x plus 20 times 200 equals 52 times x plus 200. Now, if we distribute, we have 20 times 200, which is going to give us 4,000. So this is going to be 60x plus 4,000 equals 52x plus, so 52 times 200 gives us 10,400. And now what you're going to want to do is I'm going to move the 52x to the left and move the 4,000 to the right. and we end up with 8x is equal to 6,400. And then when you divide by 8, we get that x would be equal to 800 milliliters. And that concludes number 2. Now moving on, we're going to look at number 3. So number 3 says the pressure of a quantity of an ideal gas was held constant at 764 newtons per square meter. The original temperature was 200 degrees Celsius and the original volume was 400. If the temperature was increased to 600 degrees Celsius, what was the final volume? Begin by solving for V2, then add 273 to convert degrees Celsius to kelvins. So I'm going to start on number 3 by converting my T1 from 200 degrees Celsius to kelvins by adding 273, which would give me 473 kelvins. And my T2, I'm starting with 600 degrees Celsius and I'm adding 273 to that as well. So I would get 873 kelvins. Now, the equation that I'm starting with would be P1 V1 over T1 equals P2 V2 over T2. But remember that in this problem, it says that the pressure was held constant. So that means we don't need the P2. We are given the volume. The initial volume was 400. And the initial temperature was 473. We're trying to solve for the final volume when the temperature was 873. So now you're going to cross multiply. So it would give you 473x equals 400 times 873. And then divide by 473. So we have 400 times 873 divided by 473. And we do get a decimal number, so x is going to be equal to 738.27. Now moving on, we're going to look at number 4, another word problem. So number 4 says Ronald could travel 360 miles in 1/4 the time that it took Jimmy to travel 480 miles. This was because Ronald's speed exceeded that of Jimmy by 60 miles per hour. What were the speeds and times of both? So it says that the distance of Ronald was equal to 360, and the distance of Jimmy was 480. It also says Ronald could travel in 1/4 the time. So the time of Ronald was 1/4 the time of Jimmy. And it says that Ronald's speed exceeded that of Jimmy. So the rate of Ronald equaled the rate of Jimmy plus 60. Now, we know that distance is equal to rate times time. So I'm going to change this R or dr to RRTR equals 360. And I'm going to change the dj to RJTJ equals 480. Now I'm going to plug in these variables. So I have RJ plus 60 times 1/4 TJ equals 360. Now I want to get rid of that fraction. So I'm going to multiply this whole equation by 4, which means that this is just going to turn into just TJ. And I'm going to distribute just the TJ. So that would be RJTJ plus 60 TJ equals, and you have to multiply the 360 times 4, which would be 1,440. Now I know what RJTJ is equal to because I have it right here. It's equal to 480. So I'd have 480 plus 60 TJ equals 1440. And we're going to move the 480 to the other side. So that we get 60 TJ is equal to 960. And then you're going to divide both sides by 60. And you get TJ is equal to 16. Now if TJ is equal to 16, then I can plug that into here. That would be 16 times, RJ equals 480, which means that RJ, when you divide 480 divided by 16, is equal to 30. Then if I know that RR is equal to RJ plus 60, that means I know that RR is equal to 90. And then if I know that TR is equal to 1/4 of TJ, well, 1/4 of 16 would be that TR is equal to 4. And those are the 4 things that you needed to solve for in number 4. Now moving on to number 5, we have Daisha could row 60 miles downstream in 4 hours, but required 8 hours to row 80 miles upstream. What was her speed in still water and what was the speed of the current? All right, so for number 5, we have the distance downstream is going to be 60, and the time down is going to be 4. The time up is going to be 8, and the distance up is going to be 72. Now we have 2 formulas here. We have the downstream and the upstream. So for my downstream equation, I have B plus W times TD equals DD. And for my upstream equation, I have B minus W times TU equals DU. So I'm going to plug in what I have. So the B plus W stays the same. TD is 4 and DD is 60. I'm going to distribute this 4. So I have 4B plus 4W equals 60. Over here, I have TU and DU. So I have B minus W times 8 equals 72. And you're going to distribute this 8. So you have 8B minus 8W equals 72. Now you have 2 equations that contain B and W. But notice that my W is positive in this one and negative in this one. So what I'm going to do is I'm going to actually do elimination by multiplying this equation by 2. And that would give me positive 8B plus 8W is equal to 120. Now when I add that together, the W's cancel. And you're left with 16B is equal to 192. And when you divide 192 by 16, we get that the boat speed is going to be equal to 12. Now we need to solve for what W is equal to. So you're going to take this B and plug it into this equation here to solve for what W is equal to. So that would be 4 times 12 plus 4W equals 60. So I'm going to move the 48 to the other side. And I get 4W is equal to 12. So therefore the current W is equal to 3. So remember on this problem that you do need to memorize those 2 equations because they won't be given to you on a test, but you would need to know both of them. Now moving on, we're going to look at number 9, 11, and 12. So the first thing that we're going to look at on number 9 is that we need to determine which ones are functions. And for this one, we look back to our notes for this lesson, and it says one x value cannot lead to 2 different y values, but multiple x values can lead to the same y value. Now your x values on the left and your y values are going to be on your right. So if you look at this one, I have one x value that leads to one y value, and then one x value that leads to one y value. And you can have multiple x values lead to the same y value. So this is correct. This one is a function. For B, I have 7 leads to 3 and 5 leads to 3, but 5 also leads to 4. So because one x value cannot lead to two different y values, this is not a function. Now for C, 4 leads to 5, 6 leads to 7, but M leads to nothing. So because this one doesn't lead to anything, this is not going to be a function. And this last one, I'm entering any real number into this function, and therefore, or this equation, this is going to be a function. So your answer is going to be A and D are functions. Now moving on to number 11, the first thing that I need to do is I need to solve this equation for y. So I'm going to move the 2x to the other side, and that would give me 3y is greater than negative 2x minus 3. Then I'm going to divide everything by 3. That would give me y is greater than negative 2/3 x minus 1. Now the first thing I'm going to look at is both of these don't have an equal sign, so they're both going to be dotted lines. Also, because y is greater, this is going to be shaded above. So I'm going to graph this. Okay, so the first one is going to be x is negative 2. So this is my x-axis, and negative 2 would be here. So I am going to draw a vertical line through negative 2. Now for my next one, it's going to cross the y-axis at negative 1. And my slope is negative 2 over 3. So down 2 over 3. Or up 2 over 1, 2, 3. And this one's also going to be a dotted line. Okay, so now is the shading portion. So those are my two lines. Now I have to shade. So for x is greater than 2, if I stuck the arrow in the alligator's mouth, that points to everything to the right of this dotted line. So that means I would shade all of this. Everything to the right. Now, for this one, my dotted line, I said y is greater, so I'm going to shade everything above it. So everything above the slanted line would be all of this portion here. And your answer would be the portion that's covered by both the vertical and the horizontal lines. And that would be this portion right here. So the portion above the dotted line and then to the right of that dotted line. And then lastly, number 12. The first thing that you're going to do is you're going to split up this inequality, and that's going to be negative 2 is less than negative x minus 2, and then negative x minus 2 is less than 0. We're also determining that we're graphing integers, not reals. So integers, remember, is points, not a point with an arrow. Now, my negative x minus 2. So the first thing I'm going to do is move the 2 to the other side, so add 2. So that would be 0 is less than negative x. And then I need to divide everything by negative 1. And remember, when you divide by negative 1, it flips the inequality. So this would still be 0. This would be like this. And because we want to always have the x on the left side, the only thing I'm going to do now is mirror this. So x is going to be less than 0. It's the same thing as what's there. I just flipped it, which means I flipped the inequality sign too. Now for this one, I'm going to add 2 to the other side, which would give me negative x is less than 2. Then I have to divide by -1 on this one too, which means that it's going to flip the inequality again, and I'd have x is greater than -2. So I'm going to have my number line, -4, -3, -2, -1, 0, 1, and 2 is my number line. I know that at both of these points on -2 and 0, there's going to be an open circle. -2 and 0. This arrow points to the right of -2, and this arrow points to the left of 0, which means my only point that's going to be filled in between -2 and 0 would be -1. And that concludes your questions from lesson 95A. I hope you guys all have a great day.